So the question is, it is given that P is a set of prime numbers, S is a set of square numbers, and N is the set of numbers between 10 and 90. Write each of the following statements using set notation. So for part 1, it says 7 is a prime number. So for the answer, we will write 7 is an element of P, which is a set of prime numbers. For the second question, 8 is not a square number. So you write 8 is not an element of S, since it is not a square number. For part 3, there are 6 square numbers between 10 and 90. So for this part, we have to intersect set S and set N. So what we do is we put N here, and we intersect N with S. Since they ask for 6 square numbers, put 6. So for the second question, it says that y equals square root to 4x plus 1 to the power of 3, and we need to find the derivative of this. So first, I'm going to put y or x plus 1 to the power of 3 over 2. They're being square rooted. And then we can derivative this using chain rule, which will be 3 over 2 times 4x plus 1. Take away the 1, and you multiply it again by the derivative of here, which will be 4. My bad. So and then it will be 6 to 4x plus 1 to the power of 1/2. For the second part, it says find the approximate increase in y as x increases from 6 to 6 plus p, where p is small. So for this question, we need to put dy dx multiplied by p, and then we 6 4x plus 1 1/2 times p. But we need to be aware that the x is a 6 from the question here. So we put 6 and 25 1/2 times p. Go down here, which will give us 5 times p, and the final answer will be 30p is the increase. So for number 3, we have to find the values of m for which the line y equals mx minus 5 is a tangent to the curve y equals x squared plus 3x plus 4. So right away, we can find the value of m by putting the two equations together, since they are both equivalent to y. So we can solve this equation by moving the numbers to the other side, and we will get this equals to 0. Oops, my bad. I'll put that there. So we can factorize the x from 3x minus mx, which will give us x 3 minus m plus 9 equals 0. So from this equation, we can get that m equals to 3. So that's the first m found. And for the second method, to find the other m, we can write this equation down and derivative it, differentiate it, so we can get 2x plus 3, and since y1 or dx over dy equals to m gradient, we can conclude that m 2x plus 3, and put that there, with x minus 5 equals to x squared plus 3x plus 4. So for this, we can put 2x plus squared plus 3x minus 5, which gives us x squared plus 3x plus 4. And we can solve the equation, which will give us negative 9 equals to 0. And we can put 9 on the other side, which will become positive. And we can get that x equals 3. So to get y, we can just simply put in the equation. We can put x, which equals to 3, into this equation again. So we can get 9 plus 9 plus 4. So y equals to 22. After getting both x and y, we can get the third and final, we can get the second m by putting them in the equation, which will give us 3m 22 equals 3m minus 5, which will then give us 3m equals 27, and we divide by 3, m equals 9. So for question 4, it says, in a competition, the contestants search for hidden targets which are classed as difficult, medium, or easy. In the first round, finding a difficult target scores 5 points, a medium target 3 points, and an easy target 1 point. The number of targets found by the two contestants, Claire and Denise, are shown in the table. In the second round, finding a difficult target scores 8 points, a medium target 4 points, and an easy target 2 points. In the second round, Claire finds 2 difficult, 5 medium, 2 easy targets, while Dennis finds 4 difficult, 3 medium, and 6 easy targets. And the question is, write down the sum of 2 matrix products which on evaluation would give the total score for each contestant. So for the first one, we would have to create, using the data shown in the table, we can write 4, 1, 7, 2, 5, 1 according to their scores, and we would put the other matrix as 5, 3, and 1, following the same order as their scores, and we would multiply this just like that. You'll get 30 here. And 26 here. So that's the first matrix for the first round. So I'll just write first round. For the second round, we would have to do the same thing, but using the data here. So we find that Claire finds 2 difficult. So we want to follow the same order as we did here. So we would write 2, 5, 2, Denise, 4, 3, 6. And we would put them as the same, by the same order all over again. And we'll get 40 here. Okay, 56 here, and this is the second round. Okay, so that's part 1 done. Now for the next part, we have to add these scores to calculate the total score for the 2 rounds. Okay, so what we do is just simply put down both matrix and put them down here. Like this up here is the score of Claire, and down here is the score of Denise. So we just simply add them. 82 and 82. So we get that Claire's total score is 70 and Denise's total score is 82. This is the final answer. So for the fifth question, it is given that x minus 2 is a factor of fx equals x cubed plus kx squared minus 8x minus 8. So for the first question, they asked us to find the value of the integer x. So we can simply say that x minus 2 equals 0. And so we will get x equals 2. So the next step is we would simply put it in this equation here. So we will write 2q plus k 2 square minus 2 minus 8. And you will get 8 plus 4k minus 16 minus 8, which equals to 0. You'll get that 4k equals to 16. We get that k equals to 4. So that's for the first part. And for the second part, using your value of k, find the non-integer roots of the equation fx equals 0 in the form a plus square root b, where a and b are integers. So for this part, we have to divide this equation by x minus 2 to get the quadratic equation first. So what we do is q plus 4x squared 8x minus 8 down there, x minus 2. Simply solve this. Square minus 6x squared minus 8x minus 8, and we solve it again. We get 12x here minus 8, push that out, 4x minus 8, go to the final part, and sure we'll get 4x minus 8, 0. So this is the equation that we use. Next, we will have to find the non-integer root. So one way we can do this is by using the minus b plus minus b squared plus 4ac over 2a. We can use this formula. So using this equation, so what we do is negative 6 plus minus 36 plus 4 times 1 times 4 over 2. And so we will get negative 6 plus minus, and we will get we will get 36 plus 16. Oh, my bad, I mean minus. And then get divided by 2, so we get negative 6 plus 20. So we get this, and we divide this by 2, which will give us negative 3 plus squared 5.